Okay, for notes 5.4, we're going to talk more about these binomial random variables. We're going to find an easier way to find the mean and the standard deviation than what we've done before with all the adding and dividing and all that stuff. We're going to find some probabilities involving the binomial, and we're going to try and use technology to find an easy way of doing that. Okay, so looking at a problem that we did before, we're going to apply this to our new learning here. So we had so the genetics problem, getting type O blood, we said the probability that from certain parents, the probability was 0.25 of getting type O blood, and they had 5 kids. And X is the number out of those 5 that had the type O blood. So if you remember, to find 0, we took all those things and multiplied them together to get this. Okay, as just a reminder, none of them having type O blood would mean if it's 25% they do have type O blood, it would be 75% they don't have type O blood, and we need all 5 of them. So we found the probability that X equals 0. And then you could find the probability that X equals 1, okay, which meant 1 had type O blood and 4 did not have type O blood. Then we had to multiply that by how many different combinations there were for that to get this. And for 2 to get type O blood, it means that 2 of them were positive for type O, and 3 of them out of the 5, right, did not have it. And then the different ways of doing that would be 5 choose 2, and it gave us this probability. Okay, so we found all that there. Now if you remember, the way we found the mean for all of this was we took this times this plus that times that plus that times that plus that times that, okay, etc. Now there's an easier way to do this as well. So if you actually took all those and multiplied these all together, we found a mean that would be 1.25. Okay? There's a formula we can use as well. To find the mean, we can use this formula here, we can take n times p. Okay? So in this problem, n was 5, there were 5 children, and the probability was 0.25. Okay, and if you multiply those together, you get 1.25, which is exactly the same thing as if you take that times that plus that times that plus that times that, etc. Right? So if you think about where the middle or the mean of this distribution is, you can look at an estimate, between 1 and 2 probably, right? You can find it by taking this times this, right, etc., and adding those together, or just find n times p. Now this only works if it is a binomial. Okay, so if it fits bins, right? Okay, if it's a binomial, you can use n times p, etc. Okay? Now for standard deviation. Remember, for standard deviation, we took the value minus the mean squared times the probability, and we did that for each thing. So the value minus the mean squared times probability, okay, and etc. We kept going, and then we took the square root of the whole thing. Okay? Now, you could do it that way, okay, or we have a quick formula we can use. So if it's binomial, we can use the formula is the square root of n times p times 1 minus p. So if you, in this particular problem, if you took, there were 5 kids, probability they got it, but type O blood was 25%, 1 minus 25% that they didn't get it would be 75%. And if you multiply that all out together, you get 0.968, which would be the standard deviation of the data, which would be the same thing as if you worked all of this stuff out. Okay? But once again, this formula only works if we know that it's binomial. Okay? So if we look at an example. Okay, to introduce her class to binomial distributions, this teacher does a pop quiz activity, which I did with you guys. All the questions were A through E. You had 10 multiple choice questions, and we wanted to know how many were correct out of 10. Okay, and if you remember that day, I asked you, how many would you expect to get right? So 1 out of 5, so if you had 10 questions, you answered, you'd expect 2 to get 2 right. So you were exactly right when you said that. and this is how we can find it. Now you could do all that multiplying and stuff and adding that we did before, or for the mean of x, number correct, we could just use n times p. So n, there were 10 questions, and the probability you got it right was 1 out of 5. So you multiply those together, you would expect to get 2. Okay, that's the mean. And if you thought about the distribution that we had, right? Okay, and 2 was our mean. It was right there in the middle. Okay, to calculate the standard deviation of x, you could take all that and multiply it, subtract and square it and all that stuff, or you can just take the square root of n times p times 1 minus p. So in this case, we had the square root of n, which there were 10 questions. P, the probability you get them right, was 1/5, and 1 minus p would be 4/5. Probably you get it wrong would be 4/5. Okay, so when you multiply that all together, it comes up to be 1.265. Okay, so, and also it says to interpret, right? Okay, so let's look at the interpretations. So the interpretation says if we had many students take the quiz, okay, we would expect everybody to get an average of 2 questions correct. Okay, and the standard deviation, if many students took the quiz, their scores would typically vary from the mean of that 2 by about 1.265 answers. So about 1.265 either way. Okay, so that is how you can find this for binomial, the mean and the standard deviation, pretty easily. Okay, so next we're going to find some probabilities with these. Okay, so if we look at this distribution, going back to the 5 children that with type O blood, with n and p, right? So 0 was this, so these are all those probabilities we found. Okay, so if I want to find the probability at most 1, okay, at most 1 would mean 0 or 1, right? At most 1 would be these 2. So 2 different ways you could find that. One, you could just add the probability of 0 plus the probability of 1 together, get your answer. Or the other way is at least 1 would be these 2. So you could find these, and then 1 minus these would give you those as well. Okay? So 2 different ways to do that. Okay, so if you think about this, find the probability of at least 2. Okay, at least 2 would be 2 or more. So you could take this one, plus this one, plus this one, plus this one. And if you add those all together, you get this. Or at least 2 would be these. So you could find these and take 1 minus these, and that would give you these. Okay, and that's kind of explained here. So 1 minus those 2 would give you the other probability as well. Notice 2 different ways give you the same answer, finding those probabilities. Okay, so go back to the pop quiz question. Remember the 10 questions and 1 of 5 answers being given. Here's the distribution. So Patty is one of the students in the class. Find the probability that she gets more than 2 correct answers. Okay, more than 2, 2 different ways you could do it. More than 2 would be 3 or more, right? So you could add this, right? More than 2. So not this, the sun's kind of there. More than 2 would not be these, but it'd be 3, 4, 5, 6, 7, 8, 9, or 10, right? So 2 different ways to do it. You could add this probability plus that, 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 okay? And you would get 0.3222, okay, if you add those all together. Or the little bit quicker way of doing it is you could take, if I want to know these, right, I could find these and take 1 minus these, and it would give me all this, right? So I could add 0, 1, and 2 together. If I add those together, it gives me this. And 1 minus these will give me all the rest of these. Okay? So different ways to look at that, and we did that last chapter, so I think you're pretty familiar with that. Now, what if we don't give you this, though? Okay? Then you have to use the idea that we did back, Thursday and Friday this past week to figure out these individual probabilities. Okay? And if you think about the method, so if you're thinking about this, would you want to find these 8 Yeah, 8. Would you want to find each of these 8 and then add those together? Or would you rather find 3 of them and then take 1 minus those? Which would be less work? I think this one would be less work, right? Okay, so in order to find these 3, okay, so if you remember, to find 0, we would have to find, they would have to get them all wrong, right? So 1/5 of the time they get it correct, which means 4/5 of the time they get it wrong, and that happens for all 10 questions. Okay, that gives you that there. But say they didn't give us this. Probability that x equals 1. Remember, to find this one, we got 1 question correct, and we got 9 questions wrong, and we had to figure out how many different ways that could happen. And that gives you this probability. Probability that x equals 2. Okay, 1/5 of the time we got 2 answers right, and 4/5 of the time we got 8 questions wrong. And how many different ways could that happen? Is 10 choose 2. Okay, now to find greater than 2, you could find 3, 4, 5, 6, 7, 8, 9, and 10. You could find all of those and add them together. Or if we just take these 3 and do 1 minus these 3, it'll give me what these other ones are. That would be a whole lot quicker, so you can think about which method is the quickest for you. Okay, and this is kind of showing that there. Look at another example here. Okay, Mr. Bullard's statistics class did an activity to see if students could tell the difference between bottled water and tap water. There are 21 students in the class. Each student was given 3 cups, 2 that contained tap water and 1 that contained the bottled water in a random order. The students were asked to drink the cups in a specified order and then identify which cup contained the bottled water. If we assume the students could not tell the difference, there's a 1 in 3 chance of saying it's the bottled water. X is the number of students who correctly identified the cup as containing the bottled water. Okay, so this is binary. So either they know it's, okay, if we go through and assume it's binomial. Okay, so it is either they can tell the tap water or they don't. One student is independent of the other student. There's a set number of trials. There's 21 students. And the success each time of picking it is 1/3 of the time. Okay? Right, so in this class, 13 made correct identifications. So are you convinced that that they could tell? So we want to find probability that x is greater than or equal to 13. Okay? So what I'm going to do is I'm going to show you how to do this. Well, if I didn't do it on Desmos, okay, it could be 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7, all the way up through 12, 13, 14, all the way up through last one is 21, right? Okay, so we want to know the probability of greater than or equal to 13. So I want to find these right here. Now, this would be a pain, right? Probability at 13 were correct. Okay, 21 choose 13. 13 of them were correct. That means 14, 15, 16. No, I'm sorry. Yeah. So 13 were correct. That means that 21. That means 8 of them were not correct, right? Okay. And then for this is the probability x equals 13. Then you'd have to find x equals 14 and 15 and 16 and 17 and 18, 19, 20, and 21. So you'd have to add all those together. Okay? I'm going to show you on Desmos real quick how to find that. And it's actually, yeah, so we'll go to Desmos and record that, and I'll put that in here. Okay, so for this problem, we had said that it's binomial. So go to Functions here, under Distribution. You can see binomial distribution. And the trials were 21. The probability of 1/3. Right now, these are all those probabilities. If you hit the little thing here, we see those. See a nice distribution of them. Then you can see the mean, okay, where the one that's most likely would be probably around 7 here. But anyway, and 1/3 times 21 is 7, right? Anyway, if we want to find the cumulative, we can hit this little check here for cumulative, and it gives a min and a max. So we want to know the minimum So it starts at 13, and so right now they're all highlighted, right? Okay, so from 0 to 21 is a probability of 1. They're all added together. But if we want to start at 13 and go to 21, okay, that's adding these together, okay? So 13 or more, so it's adding the 13 here, and the 14, and the 15, and the 16, all the way up to 21. Adding those all together, you get this probability right here. You get 0.0068, okay? So less than a 1% chance of that happening, okay? So that's how you can do that problem. Okay, coming back to our last problem. A local fast food restaurant is running a draw a 3, get it free. Draw it free, get it free lunch promotion. For each customer order, a touchscreen appears on the message. Press here to win a free lunch. A computer program then simulates one card being drawn at random from a deck of playing cards. If it is a 3, the customer's order is free. Okay, remember there's 4 out of the 52 cards that are 3s. Otherwise, they pay the bill. Suppose that 250 customers came in to get lunch, and X is the number of people who win a free lunch. Okay, so part number 1, why is it binomial? Okay, so you think bins. So either they win or they don't win. Each customer is independent of the other. This number of trials, there's 250 people that come in, so 250 trials. And the probability is the same for each person. 4 out of the 52 cards are 3s, so 4 out of 52 wins. Okay, so it is binomial. The mean, okay, how many people would I expect to win if there's 250? Remember, we can use n times p, so 250, and 4 out of the 52 will win. So if I multiply those together, I get a mean of 19.23. So I would expect a little bit around 19, right? If there were 250 people, I would expect around 19 people to win. Find the standard deviation of x, or we can use the find the standard deviation. It's the square root of n times p times 1 minus p. So in this case, n is 250 people. The probability was 4 out of 52. It's a horrible 4 out of 52. Anyway, let me move it all up here. And the probability of 1 minus that, you could write it as 1 minus 4 over 52, or you could say it's 48 out of 52. Either way. And if I find that answer, I'll type it in here. Okay, I get an answer of 4.21. So this is my mean. This is typically how much it differs from that mean. Okay. Okay, one of the customers is surprised when only 10 people win a free lunch. So we would expect 19, only 10 people. Okay, so what's the probability of 10 or fewer people? So the probability of 10 or fewer. So x is less than or equal to 10. So you could find 0 and 1 and 2 and 3 and 4 and 5 and 6 and all the way up to 10 and then add those all together. Or we can use Desmos. Okay, so I'll show you on Desmos how to get that as well. Okay, so with the free lunch problem, we had said that it's binomial. So go to functions, distributions, binomial distribution. There were 250 trials, 250 people. And the probability that they would win a free lunch was 4 out of the 52, right? They drew a 3, 4 out of 52. If I hit the plus button there, the zoom fit, this shows the distribution all the way from 0 people all the way up through all 250 people winning. And we had said before that our mean would be about 19.2 people, right? So right here, right at the top, there's about our mean, okay, at around 19. Okay, but that's not what it's asking us for, is it? The last part there, what's the probability that 10 or fewer? Okay, 10 or fewer. So we went to add up the probabilities from 0 to 10 or fewer. And if I zoom in, you can kind of see that it's adding these highlighted ones together. So all these different probabilities together gives you a little over 1%. So a little over 1% of the time, 10 or fewer people would get it. We'd expect 19, but it's possible 1% of the time for this to happen.